Worksheet 2, number 16. N is a known positive integer. For what value of k is the integral from 1 to k of x to the n minus 1 equal 1 over n? N is a known positive integer. Okay, so the antiderivative of the power rule is increase the power by 1, divide by the new power.
Oh, that's why it's weird.
So, because you're adding 1?
Yeah.
So increase the power by 1, that would get you to n. Divide by the new power from 1 to k. Are you solved from here? Are we good?
Yeah, I'm good.
Let me go ahead and finish it.
Yeah.
So if I plug in k, that's k to the n over n minus 1 to the n over n, and that's supposed to equal 1 over n. We're still looking for k. 1 to the n is just going to be 1. So k to the n over n equals, I'm going to add 1 over n to both sides, so I get 2 over n. And then I think I would just multiply both sides by n and get k to the n equals 2. And then I would need the nth root, or the power of 1 over n. So k would be 2 to the 1 over n, or the nth root of 2, that's the same thing. I guess I should have been looking at my answer choices to see if I was getting something close.
You did.
2 to the 1 over n. N is a known positive integer for what value of k? So that's my upper limit. When I evaluate, I get 1 over n. Okay, I think that's it.
All right.
If we look at worksheet 4, number 7. Given the values of the derivative f prime in the table, and that f of 0 equals 100, estimate f of 6 using a right-Riemann sum. So I want something with f, and I know f prime. So how do I get from f prime back to the f that I want? Antiderivative f prime to get to f. Now, is this a plus c antiderivative or a antiderivative with limits?
Number 7? It's got limits.
It's got limits, right? I get values of answers. There's no plus c anywhere. So limits from 0 to 6, which makes sense because I've got a table from 0 to 6. Although they could have extended this table out into 8, 10, 12 and just make sure you were looking at 0 to 6. F of 6 minus f of 0. Find f of 6. Okay, so f of 6 is f of 0 plus the integral from 0 to 6 of f prime of x dx. So where does the right-Riemann sum come in? What's going on here? It says you use the right-Riemann sum. That would be a right-Riemann sum is an approximation it's an area approximation. Right? It's an approximation using rectangles. So we will approximate that area with a right-Riemann sum. But we don't want to forget that it starts at 100, and then we'll do the Riemann sum part. So right-Riemann sum. So the first rectangle is 2 wide, and its height is 18, because I want to use the right-hand one. So 2 times 18. The second rectangle is 2 wide, And the height we'll use is the right-hand sum, 23.
Jeez.
And the last rectangle is 2 wide. And we'll use the height 25. So 100 plus, and then if I add all those up, 36 plus 46 plus 50 would be something with a 2 at the end, 132. And you look at your answer choices,
One of them.
and the answer is 232. But if all you do is the right Riemann sum,
That's the answer. You gotta add 100.
the right Riemann sum is 132, but that's not what they ask you to find.
You gotta add 100.
So that Riemann sum estimates the integral, but then we have to know where we started with. So this is a really, not a tricky question, but you got to be careful, because if you just kind of scan through it and you're like, oh, right Riemann sum, I'll just do the right Riemann sum and I'll get 132, and of course they included that as an answer, but that's not what they ask. So you've got to be careful on these problems. What else would you like to see? Number 6. Water is pumped out. I better be super careful about that. So I'm going to subtracting something somewhere. Pumped out of a holding tank at this rate. Liters per minute. Where T is in minutes. Since the pump started, the holding tank contains 1,000 liters of water when the pump is started. How much water in liters does it hold 1 hour later? I'm also being careful because I see minutes, hour. So let's just go ahead and change that to 60 minutes. Okay, so water is pumped out of a holding tank. So that looks like that's a rate. That's a change in water is 5 minus 5e to the negative 0.12t.
What it says pumped out, would it be negative?
So I'm still concerned about the negative. So it might be negative on top of all that. Let's be careful. So you're right to be concerned about that. That is how much it's being pumped out at. It starts at 1,000. So times 0, there's 1,000 liters. How much water does it hold 1 hour later? So water at 60 minutes is what we want. Okay, so I know about W prime or dw dt, and they're asking me about W. So how do I get from a derivative to an original?
An antiderivative.
An antiderivative. So I think I want to antiderivative W prime. Maybe we call it W prime. Maybe it'd be easier to worry about. So I want the antiderivative of W prime. And I've got values, so this isn't a plus C problem. From 0 to 60 is W of 60 minus W of 0. And looking at my answer choices, I think I know what the answer is, just looking at the answers. Because if we started at 1,000, 1 hour later we're pumping out, it can't be B. I don't think. And if I look at my options, I think that A is going to be how much is pumped out, and I think that C is going to be how much is left. That's my guess. I don't know what 83 is. Just because 258 If I started 1,000 and I add 258, I get 1258. If I started 1,000 and I lose 258, I get 741. So I'm guessing that it's C before I even do anything. Okay, so W at 60 is W at 0. And here we go. Plus 0 to 60, not 0 to 6, of W prime dt. But it's being pumped out. So I can either put the negative right here and keep this positive, or I could say, wait a minute, why don't I just make this negative and make sure I subtract whatever that number is. So let's actually work the problem and see if my guess was right here. So do I want to put it all in at once, or do I want to do it piece by piece? I think I just want to put it all in at once. So 1,000 minus math 9. Math 9 is the integral from 0 to 60. W prime 5 minus 5 e to the negative 0.12 x, x messed that up a lot here. There we go. Negative 0.12x. There we go. Dx. Uh-oh. 913. What did I mess up?
Oh, you put a 0 instead of like 0.012, which is 0.12.
Ah, thank you. There we go. 741. My guess was right. Which means I was right. 258 is how much was pumped out. So if you were going to go piece by piece, or if you just thought, let me integrate from 0 to 60, you get 258. And that's okay. You could work it kind of separately, but you have to realize that's just the amount that got pumped out. So then you would need to do 1,000 minus that to get the answer. Good question. 5 is similar, although 5 is a little bit easier on the signs because it says changing at a rate and then there's a negative, so it's going down, but that's sort of built into the formula. You don't have to worry about the pluses and minuses as much on number 5. Ooh, number 9. Do you remember what that picture looks like?
No.
Well, absolute value is a v, that's true, but absolute value over x, that function, I haven't seen that in a while. That's like the one-step function. It looks like this. They really like to ask questions about that. So you've got to remember what this function looks like. So antiderivative, yuck, I don't want to do that. But remember, this symbol means two things.
Area.
Antiderivative as well as area. So I can do area from negative 1 to 2. In fact, that's pretty easy now. That area is negative 1. That area is a positive 2. I add them together and I get 1. So that's another sort of classic type of AP problem where the computation is really easy, but you had to know what this graph was And you had to know that antiderivative also means area. And if you knew those two things, the problem doesn't take long at all.
Number 11 is just a regular derivative.
Number 11 is just a regular derivative. All these things nested together, it's definitely a chain rule issue, which makes me weary of numbers of part of answer C. Wary of it, it's not weary of it. Like, feels like there's not enough pieces to that.
Well,
So let's see.
move that out from
3 times secant squared of 4x squared times
8x.
8x is part of the answer. I'm going to go piece by piece here. The derivative of secant
Oh,
is tangent squared of 4x squared. And then lastly, the derivative of
now it's 8x.
4x squared is 8x. So then I try to put all the pieces together. 24x out front. Yep, that's on everybody. Secant squared, because everyone did the power rule of 4x squared, that's all the same.
Except for D, that's a 3 on it.
Oh, yep, that's 3, so that's out. And then 24 left off the tangent squared, or part C left off the tangent squared,
And A just didn't.
and A just did tangent. They forgot the derivative of secant is tangent squared, so the answer is B. So yeah, that's just a review problem. A chain rule review problem, no.
Number 10 is kind of hurting me. For some reason, my brain is not computing.
Cotangent squared. I'm also thinking that might be a trig identity.
Yeah, that's what I'm thinking.
Sine squared plus cosine squared is 1. That's the only one I remember. The rest I figure out. If I want cotangent to show up, then I should divide by sine squared. So 1 plus cotangent squared is 1 over sine is cosecant squared. So that's the same as the integral of cosecant squared. And let's see, the derivative of
Cotangent?
yes, derivative of tangent is secant squared, which means the derivative of cotangent is oh, wait a minute. The derivative of tangent is secant squared. The derivative of cotangent is, yeah, partly negative.
Oh. Okay.
So the antiderivative of cosecant squared would be negative cotangent of x from pi over 3 to pi over 2. So negative cotangent of pi over 2 minus cotangent of pi over 3. Free response, that would be a safe stop, and a probably good safe stop to take because I don't have those memorized. I gotta have to think about this. Cotangent is cosine over sine, or x over y. So that would just be 0. Okay, I guess they gave me one nice one. Cotangent of pi over 3. Tangent of pi over 3 is root 3. So cotangent of pi over 3 has got to be root 3 over 3. That's how I would remember that one. And then negative negative makes a positive. So I think it's answer C. But trig identity, trig derivatives, unit circle.
I'm a little confused. I don't know. I think like the bounds are 0 to 10. But what exactly is like the 90 degrees and the 20 degrees Celsius? Like, where does that fit in?
Okay, a cup of coffee at 90 degrees. So that sounds like the starting point of the coffee is put into a 20-degree room.
So then that would be 90 would be T at 0 and then 20 would be T at 10. Is that what it's
No, because it's asking tea at 10.
Okay, wait.
Coffee cup starts at 90.
R,
Well, R is the rate.
whatever you want to call the antiderivative.
The antiderivative of R. So T of 90 is, no, did that backwards. T of 0 is 90. That's what the coffee temperature at 0. 20 is the temperature of the room, so I don't know that factors in anywhere. The coffee's temperature is changing at a rate, I'm going to relabel that, T prime is negative 7 e to the negative 0.3 t. And we're looking for T at 10. So that 20, it didn't matter. I mean, it probably affects the rate, right? If the coffee is outside in the freezing cold, then that rate is probably different. But that number doesn't affect my problem. So I want to integrate T prime from 0 to 10. T of 10 minus T of 0, and then I can go from there. 15. Yes, that's been on several AP tests. It's in my AP classroom quite a few times, and we like to use it as well. Because it tests so much at once here. The graph of a function at f is shown. Okay, so this is f of x. I mean, it's labeled and it tells me, so I'm labeling it unnecessarily there. H of x is the integral from 0 to x. Which of the following must be true? We're looking at all these things at 6. So I need to know something about h prime and h double prime. So h prime, if I take the derivative of h, I get h prime. What happens if I take the derivative of the antiderivative of f? It cancels out, and I get f. And while I'm here, the second derivative of h would be the first derivative of f. So everything's at 6, so let's see if we can figure this out. H of 6 is the area from 0 to 6 of f. From 0 to 6. I can stop at 6. Without knowing much about, all I could say is that it's negative. Makes me nervous. We'll see what else we can learn here.
Equals 0.
H prime of 6
Is, that's f of t, isn't it?
is the same thing as f of 6 is 0. Okay, that's good news, because now I can definitely tell those apart. I'm just trying to put them in order, basically. And then the second derivative is the slope. The second derivative of h is the first derivative of f, which is the slope of f at 6, which is positive. Again, I don't have a positive what, I don't know, but I don't need to know. It's positive. Okay, so now I can put these in order. In fact, they landed in order nicely for me. Negative, 0, positive. So h is less than the first derivative is less than the second derivative.
Yes.
Negative is less than 0 is less than positive. Yes. So it's A. I hadn't seen one quite like that. They usually do it without this on there, and then you end up looking for the concavity of one of the spots. And it's kind of the same deal of, is it concave up or concave down, and that tells you if it's the second derivative is positive or negative.